Hello everyone. In this video, I will be discussing the concept of namespace in C++, a powerful concept introduced during the standardization of C++. I will be discussing what is a namespace, how to create it, how can we access the members of a namespace, what is global namespace, discontinuous namespace, anonymous namespace, nested namespace, and how to create an alias for a namespace. Finally, I will be discussing the concept of inline namespace. So let's go. Hello everyone. Now let's start with namespace in C++, a concept introduced during standardization of C++. Now, what is namespace? A namespace is a declarative region where identifiers are declared to manage their scope. Now, by this statement, we mean that we want to avoid naming conflicts. Suppose we are having a variable x and we are having one defined in the namespace and other defined in the main portion of the code. So what weightage or which particular x will be accessed? So if there are multiple named variables with the same name, then to manage their scope, we use the concept of namespace. Now, namespace helps us to organize the code into logical groups, where specifically when the identifiers have the same name, maybe a variable, maybe a function name, or any other thing, in multiple namespaces can exist in a program. That is, if there is a possibility that there are multiple names with the multiple variables with the same name in a program, they can be defined when they exist in the different namespace, and thus they can avoid naming conflicts. Now, same identifiers with the same namespace are visible to one another just by their names. Now, to avoid this name conflicts, we fully qualify the namespace with that of the variable or any identifier that we are using, and thus we can avoid the naming conflicts. Now, we are already using namespace std. Now, to include a namespace or to add a namespace to your code, we use the syntax using followed by the namespace and the given namespace name. Now, this is std stands for standard namespace. Now, it is basically helping the compiler to tell that all names that are part of the std namespace should be available in the code. That is the program that you are using. So it simply simplifies the usage of elements or other library components like functions, data types, classes provided by the C++ standard library into your code. Now, to understand it, let us consider an example. We have defined a namespace. Now you can look over here. We are having a variable x and y defined over here. Now these are having some values assigned to them. Now, in addition, we are using standard namespace. Now we have defined a variable x within this main code, that is a main function. Now, when we simply write access the value of x, so it will be printing us this value that we have defined in the local namespace. But if we want to use the value of x or y of this namespace, then this x is assessed by providing the fully qualified name. As I have told you, we have to add fully qualified name to provide this thing. So here x variable with the qualification of the namespace that we have and the scope resolution operator. So this particular helps to identify that we are using x. Which x? This one. That is one defined in the my namespace. So thus we can avoid naming conflicts. That is, a variable x is here and variable x is here. So in order to avoid these such type of conflict and manage their scope, as we have told that we are managing, this scope is limited, his namespace is limited to this scope. Now if we want to use it, we have to fully qualify it, and fully qualified name is being provided over here. So it helps to organize the code into logical groups. Now this is one group, and similarly if we can define multiple namespace, we can have multiple. So same name variables can be existing in the multiple namespaces. Now here we are using one is a standard namespace, and we are using one that is defined by you, and the namespace is identified by this name. So therefore we have to qualify this name with this particular variable so as to distinguish this x from this x. So these two x can be distinguished when we fully qualify the name. Now if we fully qualify, it is this one, and if we do not qualify, it is the one available in the main function, that is a local namespace. So basically the scope resolutions can be performed, and it avoids the naming conflicts as it is written over here. So this is how the namespace is done. Now to create a namespace. Now a namespace can be created. So as to make use of namespace, we use the namespace keyword. Now namespace keyword followed by the name of the namespace that we have to provide, and followed by all the declarations as we showed in the previous example, that we have used int x is equal to something. Similarly, any function or anything can be added. So this is how we had to use it. And accessing the namespace, and if we want to access the member, there is direct access using the scope resolution operator, that we have to fully qualify the name of the namespace followed by to directly access the namespace member. Now as we have shown over here, int x, and if we want to use it, we have to qualify over here. And if we do not include the standard namespace, as I've told you earlier also, std namespace is being included, and if we want to use it in a code, then we have to write using namespace std. Now as I've told you that if we do not use it, then we have to qualify std colon with the each of the variables or functions or data types or anything that is available in the standard namespace. So therefore cout has to be qualified over here because we have not mentioned it, or I make it a comment in here there. Similarly, with this endln also, I have to add this fully qualified name because I want to use it in my code. If we do not, if we want to avoid it, then you can simply include the statement using namespace std and it will work. Now let us, before discussing the other methods, let me also give you a small glimpse. Now I just add some other ways of using the namespace. Now there is a using declaration that helps us to use that namespace to bring in the specific names in the given code. Now in this particular case, what we want to use, we want using namespace x. Now this will only bring x from that namespace into your code. All other will not be included. So this is why it is given the name using specific names. That if you don't want to bring all the namespace and you want to bring some specific, then you can do it by using keyword followed by the namespace and scope resolution operator, and that particular member of that namespace can be used. Then you can use using directive as we have done in the using namespace std to bring all the names from the given namespace into the current scope, as you have been doing with using namespace std. Similarly, if we include like using namespace, then all the names, that is all the variables, though we have defined only x is equal to 5 here, but we can also add many other namespace, many other members, and all those members will be available in this current scope when we add this statement, that is to bring the all that you have to use using namespace. But if you want to use a specific, as I've been told you earlier, then you have to qualify the namespace followed by the variable name, and scope resolution operator is used as a separator. Now here we can see, here we are using the std namespace because cout has to be used. So if you use using namespace std, then it's okay. So these points are to be taken care of while working with how to create namespace and how to access namespace. Now let us discuss all these things with the help of a code. Now in order to understand the concept of namespace, let me first define the namespace that I want to create. As I've told you, first you will be using the keyword namespace followed by the namespace name, and then I will be providing the contents, that is the members of the namespace. Now here I add a int variable x and add it a value 10. Then I also add a double variable y and add a value 2.5 to it. Now if I want to use it in my code or to print some value, let me define one more variable y and let it be 5.5, 5.8 let it be. Now if I use a print statement, now I am adding the value, I'm printing the value of y. Now as I've told you that this is telling me that there is identifier is undefined. So it is not identified because I have to include the standard namespace. So for this I am adding std followed by, because I want to access it. If we want to avoid it, now let me first print it this value and see what the value is there. Now first of all, it is showing me no error and it is printing the value of y to be 5.8. But if I want, now if I want to avoid this thing, I can simply include using namespace. Now, as I've told you that there is one way, if we want to bring all the namespaces in our code, you can simply write using followed by the name of the variable namespace. Now, using namespace std indicates that all those available in the standard namespace or the standard library should be brought in use. So now if you can void it like this, so you can see still it works with no errors. So you are getting the right value. Now let me access the value of y and see what happens if I access the value of y, sorry, x. Now it is again showing me some error. Let me check what is this error. It is undefined, as I've told you earlier, because the namespace has not been included. So what I will do is I will add namespace name followed by the scope resolution operator followed by the variable that I want to access. Now if I print the value, so you can see that we are getting the value that is available in this particular namespace, that is a member of that namespace. Similarly, if I want to get the value of y that is of the member of defined, now this is defining the scope. Now this scope is limited to this namespace and this names y variable scope is limited to the main. So you can look here and I get this value. So you can look here, I'm getting here value 2.5. So clearly, if we want to access a specific member, then I have to provide the namespace followed by the scope resolution and the member variable. But if I want to use all the namespace members, then I have to include the statement and make it a standard namespace. Like I'm using all the functionality that is available in this std namespace in our code. So this is how the things work out when we are working with namespace. So let me discuss with the help of another program also. Now let us consider another program where we include a global variable x, let's say. Then we include a namespace also. I create a namespace. Let it be my namespace A. And I also add the same name variable. Let it be x over here and assign some value to it. Let us say 5. And also I add the value of the global variable. So to use it, I have to precede it with the scope resolution operator, as you can see over here. And I also add a function, let us say a display function that simply displays a message. I assume that you can see that cout is showing me the error. So I include using namespace. I've told you earlier what is the important to include all the identifiers, all the functionality that is available in the standard namespace to the code. So now otherwise we have to prefix cout with the std colon, that is a scope resolution operator. Or if you are supposed to write, I have told you like this, you can avoid it by simply including all the variables, all the identifiers and functions and all the functionality that is available in the standard namespace. So I print a message over here. Now, so this is I have added one namespace. I add another namespace. Let it be like this, and let it name be B, and variable X, let it be 15, or let me show you some, or yes, 18, and I add the value of this value. Let it be this. Okay, so this is B namespace, so I have included the statement in the my namespace B. In addition, what I do is I create a global function also, which I will be calling. Let it be passed some value, and let it be having some string str with it. So for string I have to include, so this is also done, and I add this function and a message in it. So I can add some message over here. Let it be, so you can see I've added global function also. Now I shift my focus to main, where I will be using all these. So I have defined two namespaces. Now I will be using it. So I add to include all the functions that I've defined and variables from the namespace B. I include it my namespace B. Then I define a variable that is local to it. Let me add it. Now, a very important thing I want to tell you that though you have included my namespace B and the variable X, if has to be used from the my namespace B, you still need to prefix it with my namespace B, because here X is given more precedence, or you can say more weightage when evaluating this expression, that I will show you when I will print it. Here you have to prefix, although you have included the statement where all the specified variables and functions can be included in this particular with this statement of using namespace B, but still we have to use it. I call this global function some value, let it be some different value, and some message. I also call the functions that are part of display. So when I simply write display here, because there is no problem to include display, because it will be calling the my namespace B function. So before that I call the my namespace A function, but for that I have to include, precede it with this statement only. Okay, display by this, and simply calling display will call the display function of the my namespace B, because here we have already includes all, as I've discussed here. So let me run this code and see what happens. So you can see here the variable, global variable is 17x, that is a statement that is printing, and I also add a statement. Let me add it to print the value of x over here. So now we'll see what is the value of x over here. So you can see the value is 88. Why this 88 is coming? Let me show you. 25 plus my namespace B. When I go over here, it adds the value 18 plus the value of my namespace X, that is 18 plus 25 plus 5. And for to the 5 again 40 is added. So if you add all these values, you get over here the X, that is the 88. That is 25 plus, you can see 18. It turns out to be 43. Then we add 5, 45. So 43 plus 45 is 48. So you can see over here, that the value of x is 88. So this is what I want to tell you, that if you want to bring that specific variable to that particular scope of the main function, then you have to proceed it. But if you want to include every other member that you have defined in the namespace, then you can simply use the statement. But still, if there is a name clash or conflict, that like here we have declared x is equal to 25, then irrespective of this statement, you have to include my namespace b in this code. So this is very important. Okay. Let us focus on another types of namespace, and we will be first discussing about the global namespace. Now, any code that is placed outside any namespace, that code is a part of global namespace, and it is a default namespace that is available to us. And outermost scope where declarations made outside any namespace resides, like any global variable or global function that have been using so far, you have been using, all that are part of the global namespace. Now, how to use it? Now all those variables that are part of the global namespace have global scope. So as they have global scope, they are accessible anywhere. But to access them, we have to prefix them with the scope resolution operator so as to distinguish if there are name conflicts. I mean to say that if there are two variables x and they are having the same variables name, to avoid those conflicts, we have to proceed that global or prefix the global variables or global functions with the scope resolution operator so as to distinguish that they are another variable that are part of the global namespace. So you have to do it. For example, you can see here we are having a code that is a global variable that we have added, and we have also added a global function to it. Then we have added a namespace, and we have also using the variable x. Now to distinguish this x from, and we want to also access the value that is there in the global variable x, so we have to proceed this x with scope resolution operator. This distinguishes that this is a variable that is a part of global namespace, and this is the variable that is locally declared here. So this is important thing. So when you access like this my namespace, this is the particular variable that is part of my namespace. So this will add 20 plus 10 and provide you the answer. But if you simply want to access some function, my function that you have accessed globally, and there are no name conflicts, then you can simply access it by the name. So this is an important thing that you have to consider, that if there are no name conflicts, then the variable that is part of the global variable can be used or accessed here, but because it has been already made the part of the namespace, so to avoid any naming conflicts, we have added x here with the scope resolution operator, that is indicating that it is a part of a variable that has been part of the global namespace, that is a default namespace, which is made visible with the help of this statement. So let us see a code how it is done. Now in this code, I am using a namespace that is using namespace std. This is indicating that all the elements or members that are part of the standard namespace are available in this particular code. Now I will add some variables that are global variables, like x is equal to 40. So it is being declared outside any namespace and function, so it is a part of the global namespace. So this is a global variable, and because it is external to all functions and namespace, so it is a part of the global namespace. Similarly, I add a function, let it be my function, and add a statement to it. So I add a message over here, and simply that message will be printed over here. So you can look over here, that message will be printed. Okay, just put over. Okay, so this is a function, and again this is a global function. You can say it is a part of the global namespace. Now I add my namespace. So for that I declare a namespace. Let it be a, if I'm supposed, and I add a variable over here. Now if I have told you earlier, if I want to access that X on the global variable over here, I have to put a scope resolution operator to indicate that I am accessing it, and suppose that I am also declaring a function void, because I'm having the same name function but it is a part of this namespace, so it will scope will be limited to this particular portion. So I add a statement. Okay, and moreover I want to call another function, so I also add statement. Now this function is having the same name, so to distinguish it from the function that I made part of the global namespace, I've added scope resolution operator. Now let me use this code and see how things work out. So for that, I simply say that if I am not declaring any variable, I simply write cout first and print the value of X. Okay, and see if it works. Now, according to this, it should access the value of the global variable and print its value. Let's see, it is doing it. Okay, I missed that X. So you can see over here, so it is accessing it. But if I want to access that variable that is part of my namespace, so I will be using my namespace and scope resolution operator and X also. Okay, in main function X, I'll put my namespace a colon X. Okay, so I put this value and look for the answer. So you can see here its value is 65. Why it is 65? It is 25 plus 40. Now another important thing, if I call this function my function here, so it will simply call the function that is part of the global namespace, that is the function like this in the global namespace. But if I proceed, or if I want to call the function from my namespace, its name is my function. So now if I call it, so you can look over here, it will be calling that it is a part of my names function, and it will, because I placed this call also, therefore it will be calling the global namespace function also. So the important thing is, okay, if I simply want that I need to call this function, because okay, I put this statement like this, I just comment it out and I call this function like this. Semicolon. So it's still working because there is no other function that is competing it with having a name conflict, so it can easily be called. But in order to call that function from my namespace, the same name function, because it will be having a conflict if this is there. So in order to avoid it, we proceed, we add or prefix the name of the function with the my namespace. As you can see over here, I am using this statement, and this will call the function that is my function that is part of the my namespace. So this is how the global namespace is there. Okay. Okay, now we talk about another namespace type, that is discontinuous namespace. Now, as the name suggests, that if we are having namespace members definitions spread across different parts of the code, then all that particular members are added up to that namespace. So this is well used when they are working with large projects and we are having that code spread across different header files and compilation units. So in that case, all those namespace that are declared with the same name will be added up to that particular member of those namespace. So you can look over here, we are having my namespace. Once defined, we have added X, and we have defined a variable X that is having the scope limited to this namespace. But here only we have defined X, so 20 plus the global name space value will be added over here. But again, if we define it now here in this So it can be, you can assume that it is spread across different parts of the code. So in that case, what will be adding, what will be there, that it will be, okay, so what will be there, that it will be adding to that, and in that case what will happen is, it will give us the sum of all those particular members, that is x and phi function both will be the part of this phi namespace. So you can add it to different parts of the code also. So in this case you can simply access by the name of that particular namespace followed by the scope resolution operator. So both are accessible. This shows that we can have discontinuous namespace also. Now we can also have anonymous namespace. Anonymous namespace is another type of a namespace, that is a namespace as the name suggests without a name. So anything that is entities, all the members that are made part of the anonymous space have internal linkage and are only accessible within the translation unit in which they are defined. So if we are not having any naming conflicts, then those particular members can be that should have the unique name within the translation unit, and they are accessible simply by their names. So you can see here in this code we are declared a namespace, but we have not added any name over here of the namespace. So both these particular members are accessible to the main function, but because they are not having any conflicts. But had there been conflicts, that in that case we have to specify, if x is there, then this particular x will not be called if there is another x that you have defined globally, and in that case it will not work out. So this is how the things are there in the anonymous namespace. So let me show you with the help of a code how this anonymous namespace works. Now let me show you the concept of anonymous namespace. That is, I define a namespace, but I do not add the name to that particular namespace. Now here I define a variable, let it be an x, and it be value having 15. Okay, and let me also add a function display that simply displays a message. So check for the spelling of the anonymous, ensure that they are correct. And no, and y. Okay, so in this case I have added two functions. What I do is I need to call these functions, so I can simply print the value of x. Let me see. And I get a also call this function. So you can see here I am showing to going to show you that these members can be called because they are anonymous. They are accessible unless and until there are no naming conflicts. So let me run this code, and you can see that you're getting the appropriate message that you are hoping to, because these functions that are members that are part of the anonymous namespace are made available here also. But assume that you have defined another global variable. Now as it is a global variable, so it is part of global namespace. Okay, now in this case it is showing me some ambiguity because it is not able to recognize what is x, because in order to access this x it is having a naming conflict with this. So I put, and now I call run this code. So you can see here that it is printing the value not 15. It is printing the value not 15, it is giving me the value 20. Okay, so this is the issue over here that I can resolve by putting the scope resolution operator. It is clearly distinguishing this. But if there is no such global namespace, then there is no issue. Like here also I can add over here, and if I want to have this value printed, then again there is no sense over here if I say here let me call this value x. Okay, so it is again showing me some ambiguity because I cannot do here, because here x is not accessible unless and until you provide a name. So this will also not work that have been doing earlier. But to call this function we can simply say you can say here, you can simply call this function, and let me show some x. Okay, so now this statement is working over here, and if I print the value of x here, you will find that the value is accessible. So this I want to, because it is having internal linkage over here, but because it is going outside, it is not accessible. So this indicates it is having internal linkage also. So let me run this code, and it is showing this. So this indicates it is having internal linkage also. So this is how, in case of anonymous namespace, we call these functions, and because they are anonymous, so you do not need to prefix anything, and simply by the name, unless and until they are not having any naming conflicts. Now if you add this code as a global function also, then again there will be some issues. And if I remove this statement, okay, so you can see over here it is showing me some problem over here, but again, to avoid it, I can call that function and I can execute it. Again, it is having internal linkage over here, so you cannot call it when we are having the same name. So these points you should take care of while working with anonymous namespace. Okay. Now let's discuss nested namespace. That is again a type of namespace. Now in this particular, a namespace is declared within another namespace, and hence it has got the name nested. So it is basically used in organization of code in an hierarchical manner, so that it is easier to understand and read, and to get the relationships between different entities. So by it makes easier to maintain also. So let's see how it is done. We have an outer namespace. We have defined a namespace and defined a variable as its member, x to be its member. Then we have defined another namespace within it. So this is indicating that this is a nested namespace, because we have defined and again defined the variable as. Now in order to access this particular x of the outer namespace, we have to prefix the name of the namespace. Here you can see, but for the inner namespace, you have to prefix it like this: outer namespace colon then inner namespace. So this is the prefix that you have to access if you want to access the variable that is part of the inner namespace. Then in order to access in some main function or outside, then you have to prefix both the name of the outer namespace followed by the inner namespace in the order, that is first the outer then the inner. That is also to be remembered. So this code can be executed, and you can simply say that first time it is giving me the x value 10, and next time it will be giving the value of x to be 20. So let's see. So let me show you the concept of namespace and nested namespace in particular. So namespace, and I create outer namespace, and now I add a variable int x is equal to 20 over here. Now I create another namespace. Let me create another namespace, and let it be inner namespace. Now in this particular, again you want to use a variable x and assign a value 15 to it. Okay, so I've defined this particular namespace as a nested namespace. Now in order to access this member, what I do is I also define a variable. Let's say x is equal to let it be 8. Now in order to distinguish or use this particular variable's value, I simply say local variable x is equal to, I simply say x, then I add another statement, outer namespace, and I add here, I need to add outer namespace column x, and for inner, see out is missing, okay. And for innermost namespace, that I have added, I have to prefix inner namespace also. So this is how it works out. Let me see. So you can see that all these values are accessed in this manner. And if I add a global variable also, and if we want to access that global variable, so in that case, I have to do it like this. So you can see that all these variables are accessed, and what is the basic way of accessing this? That is for local variable x. Now all these x are x, so therefore this naming conflicts are being avoided by the use of namespace, outer namespace and the innermost namespace, or whatever the name you have added to this namespace. So this is how it works in case of nested namespace. Okay. So we are now discussing another important feature that is available to us while working with namespace, specifically when nested namespace, is the namespace alias. Now, namespace alias is an alias, as you name, is an alternative name or a particular synonym for that particular. So, alternative namespace can be provided for lengthy namespaces. Now, lengthy namespaces are specifically there when we are working with nested namespace. Assume that three level of nesting or multiple more levels of nesting, and large levels of nested namespace names will be very lengthy. So, in order to avoid this, we can use the namespace alias feature, where namespace followed by the alias name and is equal to the original namespace. So it provides a more meaningful and descriptive name for that particular name. So and specifically it is used while working with the third party libraries. Now you have to add a very lengthy name and a smaller one. So how it is done? You simply say, like here we have outer namespace, then we have add nested namespace, that is inner namespace to it. So we can provide an alias like namespace O outer namespace, then namespace I outer namespace. So whenever now you access this particular namespace, you have to simply write O, because you have given the outer namespace name to be an alias with that of O. Similarly, when you have to access inner namespace, you have to simply add I instead of outer namespace, inner namespace I. So let me show you this with the help of the same code that we discussed previously. So let's go. Now I continue with the same code and I add an alias for these codes. So let me add it. I provide namespace, then I provide the new name, let it be O for the outer namespace, and I put a semicolon over here. Similarly, I add the name for namespace I. So in this case, I have to be careful. I have to proceed, the order should be right. Now what can be done over here, since I have provided an alias, I can simply write O over here. And similarly, in the other case, I can simply write I over here. So let's see how it works out. So it's still working. You can see over here we have provided an alias for outer namespace, and here alias for inner namespace. So this is how the things work. You have to simply write O and I because you have provided an alternative names for these lengthy namespace. So this is an important thing that you can helpful while working with large level of nesting. And you have this, you can see that you have to type all this thing. So in order to avoid this, you can simply write I, because we have provided this statement which is giving you the alias for this thing. Okay. Now let's discuss another important concept of inline namespace, that is basically used to add versioning capabilities specifically while working with nesting namespace. So contents that are marked inline are automatically included in the initial version of the namespace. That is, if you want to control versions, then in that case you provide it with the inline keyword and add an inline keyword to the namespace, so you can control which version you want to work with. So this is basically expansion of the namespace and maintain backward compatibility, so to ensure this particular thing. Now suppose you have a particular my namespace, okay, and in that case you can add to that particular or define the new version of inline namespace by providing the keyword inline, and then you need to call this namespace by the namespace like this, my namespace followed by the version number and followed by the function. So in this case you have to specify the complete version, and otherwise if you provide it simply by my namespace, then it will not work. It will say overloaded. So in that case you can include this particular namespace, and similarly you can similarly add another inline namespace v1, and then you can control v1 colon, then you can call that. So let me show you with the help of an example how it works. So let me show you the concept of inline namespace. For this I create a namespace and add some variable x to it, and I use a function void display, let it be initial version is being called. Okay, now what I can do is I can call this function. Now I provide a new namespace, or you can say it is basically adding to that namespace. I remove this, then I add another version to this, and I add another version to it. So in this case this is this updated version, of this function. So let me call these functions one by one, and you can, as you know, let me first print the value of x. Now from my namespace colon x, or I can write it like this. So I'm accessing the value of x over here. You can leave, and I'm calling now the function. Now if I simply call this function my namespace and I prefix v2, another namespace that I've added it, and though it is inline, and I then call this function display, which is made the part of it. Now if I run this code, you can see the updated version, but if I remove this, then it is showing me that overloaded function problem is there, and this ambiguity is arising due to overloaded because it cannot distinguish which display to call. So in order to avoid it, what I can do is I can put another inline version over here, and I can include it like this. Okay, I remove this for the time being, or I comment it out. Now my namespace inline, there is some error, or I'm putting some lesser brackets, matches, then inline namespace is not ending over here. Okay, so you can look here. Now I can overcome this problem over here, like if I provide v2, so it will be calling the version 2. Let me comment out this because I have removed this. Okay, so if I call this, it will be calling the updated version because I have not changed it. Let me initial version. Okay, so if I call this, you get the message updated version, and if I call like this, so this way I can control which version of that particular function I need to call. Now it is calling the initial version. So you can look here, depending upon v1 I can ensure. So in a nested namespace, now basically this is nested, and in this I have included inline to indicate which version to be called. So this can be there, or otherwise also you have seen that by updated version we can call the updated version of this particular namespace. Okay.
Subscribe, like, share.